the last part of this section deals with solving radical inequalities. So this is when we have a variable inside of our radical with our inequality symbols. And to solve when we have an even root, we're actually going to be solving in two pieces because we have to, since we're going to have a range of numbers for the answer, we have to take the domain into consideration. So really when we solve a radical inequality and we have an even root, so if it's an odd root, we just solve the inequality as if it were an equation. But if it's an even root, then we have to take, again, that domain into consideration. So we're going to solve the inequality itself, but then we have to go back and solve just the piece underneath the radical. So this is going to be a two-part process for the solving. And then after we figure those numbers out, we are going to put it on a number line and test numbers to see where our shading would go. And then we're going to write our final answer in interval notation. All right. So let's just start by solving the inequality piece. So I'm going to just subtract the 3. So we will have the square root of 5x minus 10 less than or equal to 5. And then we'll have to square each side. So this will give us 5x minus 10 less than or equal to 25. Add the 10. So 5x is less than or equal to 35. And then we would divide by 5 to get x less than or equal to 7. Okay. So that's the first part of our problem. So now we have to go back and consider the domain. And your domain is determined by what's underneath the radical, because remember, we're not allowed to take the square root of a negative number. So I'm going to take what's inside here, so that 5x minus 10, and that has to be greater than or equal to 0. Okay? So we're always going to use greater than or equal to 0 for the second part of this problem. And then we're just going to get x by itself. So we're going to add the 10. So 5x is greater than or equal to 10, and then divide by 5 to get 2. So now we're going to consider the number line. So if I make a number line, we have 2 and we have 7, and we have less than 7, so this direction, and then greater than 2, which is this direction. So our answer should be in the middle here. But we are going to check to make sure that that is the case. So we're going to test a number in our shaded area. So let's test, should it matter? Let's test 4. Okay. So we're going to substitute 4 into this inequality and solve it. And actually, I'm just going to go ahead and subtract my 3 over right away. So when we're testing, we're going to test into the square root of 5x minus 10 less than or equal to 5. And when we test, that has to be a true statement. So again, we're going to start with 4. So if I test 4, 5 times 4 is 20. And then we have 20 minus 10, which is the square root of 10. And that has to be less than or equal to 5. So just to help us, we're going to grab a calculator. And we're going to do the square root of 10. So square root of 10. And we get 3.2. which is less than or equal to 5, so that is a true statement. Okay. And just to make sure that it's not going to be this whole line, we want to test a number outside of our shaded area. So let's just go ahead and test 0, because that should be fairly easy. So if I substitute 0 in, 5 times 0 would be 0. So then we would have the square root of negative 10, less than or equal to 5. Well, we can't take the square root of a negative, so this is a false statement. Okay. So I know that I have the right area shaded. So then my final answer are going to be all the numbers in between 2 and 7. So we're going to have a bracket, 2, comma, 7 with a bracket, since these are closed dots. So this is our final answer to the problem. All right, let's try another example. So again, we're just going to go through and solve the inequality. So we're going to start by subtracting the 1. So square root of 2x plus 2 greater than or equal to 4. Square each side. So 2x plus 2 is greater than or equal to 16. and then we would subtract the 2. So 2x is greater than or equal to 14, and then divide to get 7. So that's the first part. So now we're going to go through and take whatever's underneath, so 2x plus 2, and that has to be greater than or equal to 0. And again, that's because we can't take an even root of a negative number, so it has to be a positive. And then we're just going to solve this. So we're going to subtract the 2, and then divide by 2, so x has to be greater than or equal to negative 1. So again, now we just are going to put this on a number line here. All right, so we have negative 1, closed circle, and we have 7 with a closed circle. So looking at this, we're actually shading the same way. So now, for the check, we just have to figure out where our answer is going to be. So this time I'm going to start by testing an area outside of our radical. And again, when I'm testing, if I just subtract the 1, the statement, the square root of 2x plus 2, greater than or equal to 4, has to be a true statement. So let's test, let's just test, maybe pick an easy one, negative 10. So if I substitute negative 10 in, 2 times negative 10 is negative 20, plus 2 is going to be the square root of negative 18. Well, this is already false because we're trying to take the square root of a negative. Okay. So now if I test in the middle, so 0 is in between negative 1 and 7. So if I substitute 0 in, we would be left with the square root of 2 greater than or equal to 4. So again, using the calculator, if we take the square root of 2 just to get an idea of that approximation, so 1.4. 1.4 is not greater than 4, so I actually can't include anything in between those two. And then I'm just going to test a number on the other side of the 0. So this is going to be, let's just pick 10. And again, you can pick any numbers you want. I'm just trying to pick easy numbers to multiply by. So 2 times 10 is 20, plus 2 is the square root of 22, greater than or equal to 4. So again, using the calculator, square root of 22 is about 4.7, which is greater than 4, so that is a true statement. So our shaded area is really just on this side. So for the answer then, it's going to be everything from 7 with a bracket all the way up to positive infinity. So that is our final answer for the x values that we would be able to pick to make that statement true. All right, one more example. Okay, so again, we're just going to start by solving our inequality as is. So we're going to add the 2. So square root of 4x minus 4 has to be less than 6. Okay, square each side. So 4x minus 4 is less than 36. And we're going to add the 4, so 4x is less than 40, and then divide to get x less than 10. Then we take what's underneath the radical. Okay, so 4x minus 4, and that has to be greater than or equal to 0. So we would add the 4, and then divide to get greater than or equal to 1. And then we just have to use our number line to help us figure out our final answer. All right, so we have 1 and 10. And let's see, we have an open circle, so we are shading in opposite directions. So 1 is this way, 10 is this way. So again, we just need to pick numbers to test. And again, I'm going to add that 2 over. So when we're checking against the square root of 4x minus 4 less than 6. Okay, so I'm going to start by picking a number outside. So let's test 0. So this would give us the square root of negative 4 less than 6, which is already a false statement because we can't take the square root of a negative. And if we test a number in between, so let's just maybe test 5. So 4 times 5 is 20, and then minus 4 would be 16. So we have the square root of 16 less than 6. So 4 less than 6 is a true statement. So this, we are going to have the shaded part. And then just to double check, we want to test a number on the outside of it. So let's maybe pick, I don't know, 20. So 4 times 20 is going to be 80. And then 80 minus 4 is 76 in our radical. And again, using the calculator. So square root of 76 is about 8.7, which is not less than 6. Okay, so that means that our shading is in between. So our final answer has to be between 1 and 10. 1 is included, so we have a bracket. 10 is not because of that open circle, so that's a parenthesis. And this is going to be our final simplified answer. And that is also going to conclude this section as well as the chapter.